In this video, we're going to look at graphing a square root function, which is an example of a type of equation. I'm not going to go into what functions are in this video, but for those of you that haven't had any experience with functions, you could also just think of this as an equation. So here it is written as a function. We say f of x equals square root x, and we're going to graph this. Now, if you haven't had any experience with functions, you can think of this as y equals the square root of x, and we can graph it the same way. After we get done graphing it, I'm going to talk about what the domain and range are of this function. So if you haven't had any experience with functions, that may be something that you want to go review or possibly ignore if you don't need it. Alright, so let's get into this here. We're going to graph this basic square root function using a table. So let's set up a table, x and y, and we're going to pick values for x and figure out what y is, and then just plot the points. And you can do this with pretty much any function or equation as far as graphing, at least when you're starting out, to sort of learn about how it works and what kind of numbers you can put in for x and stuff like that. So let's see, let's put 0 in for x. Alright, so to figure out y, or f of x is the same as y. All we're going to do is plug 0 in for x, so basically we have the square root of 0, which is 0. Alright, now how about a negative number? Can we put a negative number in there? Let's say we put in -1. Can we take the square root of -1? No, we can't. We can't take the square root of any negative numbers because nothing squared gives you a negative. These would give you imaginary numbers if you have experience with that. But for graphing, we cannot pick any negative values of x. We got to stick with the positives. So what's an easy number to take the square root of? Well, 1 is an easy number. Let's do the square root of 1. What times itself is 1? That would be 1. The next perfect square is 4. So what's the square root of 4? That would be 2. Alright, the next perfect square is 9. What's the square root of 9? That would be 3. Alright, let's plot these points and see what we've got. So we've got the point 0, 0, which is right here. The point 1, 1, over 1, up 1, 4, 2, over 4, up 2, 9, 3, over 9, up 3. Alright, so what we end up with, it looks like we're going to get a shape sort of like a curve here. Like I said, we can't pick any negative values for x, so this is going to be the starting spot. To give us a few more points, let's pick some more x values and bring in the calculator to figure out what the values are. So let's pick 2. Alright, so we need to figure out what is the square root of 2. So let's punch that in. 2 square root. That's about, well, obviously, you know, you got an irrational number here with massive decimals, infinite decimal values, and no repeating. So for graphing, I think rounding to the nearest tenth is about as accurate as we're going to get. There's no reason to go to the hundredth on our graph. So 1.4, let's write that down, 1.4. Alright, let's do 3. So we need the square root of 3. 3 square root is 1.7. And we've got 4. Let's do 5. And then we'll graph those points. 5 square root is 2.2. 2.2. Alright, 2, 1.4. See, this is getting a little tricky here, especially with this tiny graph. So just about 1.5. 3, 1.7. It's getting closer to 2. 5, 2.2. Just above 2. Okay, so you can see this curve is starting to fill in, and we could continue with 6, 7, 8, 9, 10. And basically we're going to get, oops, let's undo that. That wasn't a good start. Let's see if I can make this smoother. We're going to get a nice smooth curve. Oh, that's pretty good. Like that. And it's going to continue on forever in that direction. Now, if you've done some graphing with parabolas, this is actually half of a parabola shape. If you took a parabola that you're used to seeing going up or down, cut it in half and turned it sideways, that's a square root function. And this is what all square root graphs are basically going to look like. They're going to look like this half a parabola shape, all right? It might be shifted up, left, or right, which we're going to see in a minute, or flipped over. But this is the general shape when you're looking at graphing a function that has a square root in it. Let's talk about the domain and range of this. So if you recall, domain are all the x values. Well, let's think a minute. What kind of values for x could we plug in? Or maybe another way to think of it is, what x values could we not plug in? In other words, if we plugged it in, we didn't get a y value. What kinds of x values actually gave us a y value? Remember, the negatives were the ones that caused us troubles. So if you look at your graph, your x values here start at 0 and go to infinity. So the domain, written in interval notation, would be 0 to infinity. If you wanted to write it as an inequality, you could write it like this, the set of all. Actually, we don't need that part. We could just say x is greater than or equal to 0. And if you're familiar with set builder notation, you could say the set of all x such that. Something like that. Just depending on how your book or your instructor likes it written. Alright, how about the range? So the range are the y values. Well, you kind of look at our y value chart here, 0, 1, 2, 3, and look at our graph. Our smallest y value is 0, and my y values are going up. They will continue to go up and up and up and up and up at a much slower pace than the x's, but they will continue to go to infinity. So we have the same exact range, and this won't always be the case, just in this case, from 0 to infinity. So we could write the range is y greater than or equal to 0. Again, depending on how your instructor wants it written out. Alright, let's look at another example. Let's change this just a tad and see what it looks like. We'll get rid of all this and bring in another graph. So you got the basic idea now, and we'll just change it up. Let's do f of x equals the square root of x plus 2. Alright, well, let's start off with the xy chart again, or x, f of x, same thing. Remember, you can think of this as f of x. And let's pick some values for x. Well, now let's think about the smallest x value we could put in here. Remember, what's underneath the square root? Let's pick a different color here. Oops, okay. What's underneath the square root right here, this part, has to be a positive number. It can't be negative. It could go all the way down to 0. So what x value is going to make the radicand is what's underneath the radical. What's going to make that 0? What x value? Well, that would be negative 2. So if we pick x to be negative 2, then we have y equals the square root of negative 2 plus 2, which is just the square root of 0, which is 0. So we can pick a negative x value here. That's okay because of the plus 2 in the radicand. When we add 2 to the negative 2, we end up with 0. So it's not necessarily that you can't have a negative x value. It's just that your radicand, what's underneath the radical sign, has to be 0 or bigger. Alright, so let's pick another x value. We're going to have to get bigger. See, if we pick a smaller x like negative 4, then we'd have negative 4 plus 2, which is a negative number, and we can't take the square root of a negative, so that's no good. So we can't pick any x value smaller than negative 2. Alright, let's go up to 0 and see what happens. So we get y equals the square root of 0 plus 2, which is the square root of 2, which we saw from the calculator was 1.4. Okay, let's try, you just pick whatever x values you want. You can start graphing it as you go along if you want. So negative 2, 0, 0, 1.4. See, we're getting this same shape. We're going to get this same shape again here. You could try to make the square root come out nice. Let's see, if we pick x to be 2, we get y equals the square root of 2 plus 2, which is the square root of 4, which we know is 2. So that one came out nice, 2, 2. You know the numbers under here that make it nice, which are 0, your perfect squares, 0, 1, 4, 9, 16, if it'll fit on your graph. If we can make what's underneath here come out to be one of those numbers, we get a perfect square. So let's say we want to make it come out to be 9 underneath here, so x would have to be 7, because 7 plus 2 is 9. So we get y equals the square root of 7 plus 2, which is the square root of 9, which is 3. So over 7 up 3. And that's pretty good. If you know the basic shape of a square root, you can just do a few points and then fill in the rest. Now what happened, let's look at what happened from the last one we graphed, if you remember. If we look at the last one we graphed, f of x equals the square root of x, remember it started here, and then it kind of went like that. This isn't going to be perfect, but... So when we took what was underneath the radical sign and we added 2, what happened to the graph? It just shifted 2 units to the left, which is a little bit counterintuitive because it's adding 2, so you think it might go to the right. But if you add 2, it's going to go to the left. If you actually minus 2, it would move to the right. And you would see that if you plotted some points. We're going to look at a graphing utility in a second, which will show us that in a much faster way than plotting points. Let's talk about the domain and range of f of x equals square root of x plus 2, the domain of our blue graph. Okay, let's look at our blue graph here. So our smallest x value now is all the way down here at -2, and it continues to infinity. So your domain starts at -2 and goes to infinity. How about your range? What's your smallest y value? 0, and again going up, so your range starts at 0 and goes to infinity. And you could do this for any square root function, is just make a table and start plotting points, and it really helps to have an idea about what the shape is going to look like. You should memorize that a square root function is going to have this half a parabola curved shape to it. So you can go online and Google any graphing utility. This is just a graphing calculator I found online. Just Google graphing calculator online. Or you might have your own graphing calculator. And you can kind of experiment with different graphs. Let's do the square root of, well, I told you that x minus 2 would shift the other way. Let's look at that one. The square root of x minus, x, there we go, minus 2. Graph. Oops, I got to put a parenthesis in there. The graphing calculators don't always require a parenthesis, but it looks like this online graphing utility likes you to close your parentheses. So here's the graph. So notice we have this shape again, but it shifted 2 units to the right. I did -2, but it shifted 2 units to the right, and we have this same shape again. Now, what would happen if we did the square root of x and then close the parentheses and put the -2 outside? Let's look at what that looks like. So this is in blue. So with the -2 outside, it shifted it down. Notice we have the same exact shape, but it shifted the graph down. Okay, so let me see if I can write that out for you. So you have your basic square root shape, which was the very first one we did. And then if you have something like f of x equals the square root of x plus a number inside the parentheses here, whatever that c is, some number like 2, that's going to shift your graph c units to the left. If you have f of x equals the square root of x minus c, it's going to shift c units right. If you have f of x equals the square root of x and then a plus c on the outside, so the plus c is not underneath the square root, it's going to shift it c units up. And if you have f of x equals the square root of x with the minus c outside the parenthesis, that's going to shift c units down. And graphs have this shifting, oops, that W is a little ugly, this shifting property. All different kinds of graphs have this same kind of shifting pattern. So you might see this with parabolas, sine graphs, whatever. You're going to, anytime you have the plus or minus a number that's inside your function, that's going to shift it left or right. If you have your plus or minus a number sort of tacked on the outside of your function, your basic function, it's going to shift it up and down. This is a common trait of graphs. So let's look at that. Let's look at a shift up and shift down just so you can see one more of those. We did a shift down, but let's show your basic square root function, and then let's do minus 3. So what's that going to do? Minus 3. It's going to shift it which way? It's outside of the square root, so it's going to shift it down 3 units. Let's look at the graph. There it goes, down 3 units. So something that's a little weird to get used to, or something to think about, when you think of plus c, you would think of going to the right, but it's not. It's to the left. And minus c. So this left and right shifting is counterintuitive. And this is one thing that drives people crazy about math, but it's just the way that it is. So if it's plus c, it's going to go left. If it's minus c, it's going to go right. So the left and right is counterintuitive, where the up and down is exactly what you'd think. A plus c shifts it up, and a minus c shifts it down. So that's just something to be aware of. Okay. Let's say let's do a green one. We do square root of x minus 3 in the parentheses. X minus 3. So the minus 3 is in the parentheses. So what's that going to do? Since it's inside the parentheses, it's going to go left or right. Okay, remember the left or right shifting is a little bit counterintuitive. So since it's minus 3, it's going to shift it to the right. Let's take a look. Our green graph should be 3 units to the right. There it is right there. Notice all these shapes, the red, green, and blue, are pretty much the same shape. They're just shifted around. And this is your basic idea of a square root function. All right, what's the domain of this green one? What's the domain of the green one? All right, hopefully you have it. It would be 3 to infinity. So you'd have a hard parenthesis, a 3, not a hard parenthesis, a bracket, a 3, and then infinity, or x is greater than or equal to 3. And what's the range of this one, this green one? Y is greater than or equal to 0. So far all of our ranges have been greater than or equal to 0, but this blue one right here, the range of this blue one, your y's go all the way down to negative 3. So your range would be negative 3 to infinity, because your y values go down that far. Alright, well I hope that helps and gives you a general idea of graphing a square root function. If you can't remember these things on a test, all this shifting, you can always just do an XY table. You know, pick values for x, plot y, use your calculator, do the decimals, and just get a general shape of it. But you do want to memorize, you know, that the general shape of a square root function is going to look something like this. The only time it would flip over, if you had f of x equals and you had a negative in front of your square root, that's going to flip it over. Let me show you that here so you can see what that looks like. So let's put a negative sign in front of that square root. Let's get rid of these. Graph. So see, that just flipped it over. So a square root is going to be this way, you know, up, and then a negative square root is going to be flipped over. If you put, let's go back to the equations. If I put something inside this parenthesis, let's say like a minus 2 inside the parenthesis, so that's a left or right shift, counterintuitive, so it's going to go to the right 2 because of this negative 2 in the parentheses, and then it's going to flip it over because of the negative. Let's look at it. There it goes. So the negative flipped it over, and the minus 2 inside the square root shifted it 2 units to the right. So all these things kind of work together. in combination to manipulate your basic square root shape.